About carbon monoxide sources and effects.
Sources of carbon monoxide. Carbon monoxide can come from kerosene and gas-based heaters, leaking chimney and furnaces, fireplace, gas stove, generator, and other gasoline-powered equipment. Automobile exhaust from attached garages and tobacco smoke. Truck or bus exhaust from attached garages, nearby roads or parking areas can also be a source. Nature of pollutant. Carbon monoxide is a colorless, odorless, poisonous gas formed when carbon in fuels is not burned completely. It is a byproduct of highway vehicle exhaust, which contribute to about 60% of all CO emissions nationwide. In cities, automobile exhaust can cause as much as 95% of all CO emissions. These emissions can result in high concentrations of CO, particularly in local areas with heavy traffic congestions. Other sources of CO emissions include industrial processes with fuel combustion in sources such as boilers and incinerators.
Carbon monoxide enters the bloodstream and reduces oxygen delivery to the body's organs and tissues. The health threat from exposure to carbon monoxide is most serious for those who suffer from cardiovascular disease. Healthy individuals are also affected, but only at higher levels of exposure. Exposure to elevated carbon monoxide levels is associated with visual impairment, reduced work capacity, and reduced manual dexterity, poor learning ability, and difficulty in performing complex tasks. EPA's health-based National Air Quality Standard for carbon monoxide is 9 parts per million, measured as an annual second maximum 8-hour average concentration.
Environmental effects. Although carbon monoxide is only a weak greenhouse gas, its influence on climate goes beyond its direct effects. Its presence affects concentrations of other greenhouse gases, including methane, tropospheric ozone, and carbon dioxide. Carbon monoxide readily reacts with hydroxyl radical, forming a much stronger greenhouse, which is carbon dioxide. This in turn increases concentrations of methane, other strong greenhouse gases, because the most common way methane is removed from the atmosphere is when it reacts with OH, which is hydroxide. So, the formation of carbon dioxide leaves fewer hydroxide for methane to react with, thus increasing methane's concentration. A NASA report indicates that carbon monoxide is responsible for a 13% reduction in hydroxyl concentrations and through other reactions, a 9% drop in sulfate concentrations. Sulfates are credited for offsetting some of the global warming due to greenhouse gases by reflecting incident solar radiation back to space.
Thank you.